Good afternoon, everyone. Thanks for coming for this particular session. Hopefully, with this 1 hour of session that we are able to learn about something on Lean and something on simulation as well. So let me just run through the slide. So today's our topic for today is applying Lean methodology through simulation. And my name is David. Some agenda for today. First, I will have a short introduction of the company and also what is Lean about. When we talk about Leans, we always talk about operation waste and how does it actually relate to our daily operation cost. I think nowadays we are getting more competitive and everything is the price is going up. But how can we actually able to look at our operation costs and we are able to reduce them through reducing the waste such that we can be more competitive with the others. Then subsequently, we will take a look what is computer simulation, the use of computer simulation. And finally, we will end up the whole thing with a case study that is using the computer simulation to justify Lean implementation in a book processing operation. And subsequently, we will have a Q&A. Just a little bit on myself. I'm director of the company Advent2 Labs Consultation Private Limited. I've been working with the automation industry for a couple of years. Subsequently, I was also teaching in some of the local poly. Currently, I'm also one of the adjunct faculty member in the SIT as well. Along my experience, beside automation, robotics, and mechatronics, I'm also involved in industrial engineering, operation management, and hence Lean will be something that is quite important in the operation management. And also for the last 10 years, I've been involved in the simulation as well. So hopefully through today's session, I'm able to share with you what's the use of simulation and also how can simulation be tied together with operation management and also Lean implementation. A little bit on my company profile. Our company is a consultation company. We focus on how can we help our customer in terms of improving their business processes. So we have been working in some of the software, industrial software development, factory automation, and implementing Lean. And most of our customers come from the manufacturing sector, logistic distribution, and for the past few years, we have been also involved in the healthcare operation. So we actually help company in terms of studying, improving their organization efficiency. What we'll do is actually we make use of a simulation model and by putting in the actual operation parameters, and we use it for a platform for analysis. And we also provide the pre and post sales support to the simulation software they are distributing, which is Flexim. We support the whole Southeast Asia region. These are some of our customer profile. So some of them, actually, as I said, majority come from manufacturing. So some of them actually come from semiconductor industry. Some of them, they come from so-called high consumer industry, electronic. Even we have company that is from so-called aerospace industry as well. Yeah. And we also work with a customer that's from the healthcare and such as the NHG Group, National Eye Center, Woodland, Sengkang Hospital, in terms of their operation planning and also the before they actually move in, they did a layout study about their new premise that they have. And other than that, we also work around with the warehouse and logistic area. Company like Syngenta, which is an agricultural insecticide company. They did a project with us to study into their internal warehouse operation. We also have Pepsi Cola, Keppel, Logistic, so on and so forth. Right. So these are some of the customers that we have in the past few years. So let's take a look in today's synopsis, what we wanted to touch on this particular presentation. Lean is actually a philosophy to identify, reduce, and eliminate operation that does not add value to the final feature of the good and services for the customer. So therefore, in the sense that anything that does not enhance the final feature of the good and services, in Lean, they treat it as waste. So how can we, in the sense, identify them, reduce them, and also eliminate them, such that we are able to produce something that able to meet the customer requirement? So by adopting Lean in the operation, definitely changes will take place. All right, a lot of things will take place. The mindset will take place, will change. The mindset change will take place, and also in terms of the operation flow will take place. Then how can we, in the sense, allow the management to able to manage the change properly? So simulation become a very important aspect to help the management to be able to see what is going to be like when changes take place, and also it helps to manage the expectation of the management and also reduce the potential risk of the implementation. So by adopting simulation, in fact, we help company in managing the change. So they will be able to understand what will be the impact be. Is there any risk involved? And if there's any changes, what kind of changes will take place? And through simulation, kind of crystal ball, we are able to manage this kind of change for the management. Now, first, what is Lean? Lean basically is to keep away the unwanted waste, all right? To keep away the unwanted waste so that we can maintain ourselves as a V-shaped body, all right? Our body has a lot of fats, and these fats actually uses our body resources or energy, and hence, actually, it might trigger kind of health hazard for our body as well, even though they are not that useful. But they are actually using a lot of our body resources. Hence, therefore, by reducing body fat, potentially we can become healthier. Yeah. So I think for the past 2 years, a lot of people are getting to do more and more exercises to keep themselves lean, and hence to reduce the body fats. At the same time, they are much more healthier nowadays. And in the perspective of operation management, Lean is an initiative to remove, reduce, and combine operations that does not contribute value to the business goal or to the customer. And Lean is actually developed by Toyota, and it is also previously known as a Toyota Production System, TPS, in the 1948 to 1975, when Japan is actually facing a very poor economic growth. And Lean actually helped them to reduce their operation costs within Toyota and making them to become more competitive and able to get a comeback, all right, later date. And Lean is also known as the other term, which is just in time. So you are producing something just in time when there is a need. All right, you do not produce something that is before time. You don't produce something that is after time. So when there is a need, there is a demand, that is where actually we will produce according to that particular demand is, and hence there will be not too much extra and there will be not lack of anything. Yeah, so that is what of the mindset of Lean is all about. The other thing about Lean is talking about value. Value is what your organization can bring to your customer in the form of goods and services. All right, so for example, if you have a mobile phone, the value of the mobile phone is that you can call out to somebody. All right, and if that particular mobile phone does not have this particular value, that mobile phone to you is of no use. So therefore, when during the manufacturing process, during the value adding process, we are adding this kind of business function or engineering features to the good and services such that it will able to meet the intended value of the customer or the business. And nowadays, we know that our handphone is actually come together with a camera. Maybe in about 10 or 20 years ago, when we started to use mobile phone, we do not have that intent purpose. Nowadays, camera becomes something that become a must. In those days, if you have a camera, it's a good to have, but nowadays become a must-have feature. So I would like to bring out a point is that sometimes our value add to the customer could be something in the past is good to have, but nowadays become a must-have feature in order for us to be more competitive. But however, what I'm trying to bring across is that whatever activities that we are trying to enhance the feature, to build on the features of the goods and services is something that we call it value-added activities that is required in our business and in our operation. And hence, these are some of the examples which I mentioned earlier about the mobile phone. The other example over here is lately I visited Decathlon. If you have visited them, they do have a self-checkout apps, all right, so that you actually can scan the barcode on the commodity, and immediately you can make your payment through the app, and you just have to walk up. Yeah, and this particular app itself is a kind of lean because they actually reduces the customer waiting time. All right, reduces customer waiting time. So customer basically they are there, they would like to purchase something. After that, they make a payment, they go off. All right, so I think getting something is what the customer want. Yeah, so making payment, waiting, all this is not really in the sense that is customer going there to for that particular purpose. Hence, we try to reduce the time on that area. So by having such an app, I think it is a very good so-called application about the lean, and we are able to reduce the waiting time for the customer to check out their items. The other area will be clarity. All right, if something, for example, a signboard is not clear, then in the sense that people will actually spend time in looking for the place, and it will create a lot of bad customer experience. So for example, if you are going to the community center to collect your CDC voucher, if they have a proper good signage, we're able to lead the customer to the right location to make the collection. So basically, we are trying to reduce the error, all right, of going to the wrong place as well. So in fact, these are some of the example of lean and the value of lean, all right, that when we're able to reduce the waiting time, we are able to improve the quality, we are able to reduce the error, we are actually reducing the operation cost. And as we become our operation cost reduced, we can become more competitive in the market. So the non-value added activities are things that does not add on features, all right, which for example, maybe you produce a bad so-called product, all right, the time is spent, all right, the time is spent, but the product cannot be consumed. So therefore, this is considered a non-value added kind of activity. Yeah, so it actually add on the operation cost to the business, but does not increase the customer satisfaction. It does not enhance the feature of the goods and services that the customer receive. And hence, whatever that is being done is a waste in the operation. Yeah. So what are the ways that we have? In generally, lean, they classify a few types of waste. One is your process waste, all right? Method waste, movement waste, defects, overproduction, untapped talent, waiting time, inventory, all right? So these are generally the 7 ways that we can find in the industry, in the operation itself. I think waiting time, everybody understand, because if you are waiting and you are not doing anything, you'll find it's a waste of time. And as for the production, if the product or the semi-finished product is waited to be processed, there's nothing enhanced on the goods and service itself. So it actually become a waste. As for inventory, if you have built up the inventory, but in the sense that it is not being consumed, all right, or maybe it is waiting to be consumed even next month. So you take up space. And when you take up space, you take up storage, you take up the resource to take care of the inventory, this actually become a form of waste. So these are kind of example of ways that we have normally in our operation. By identifying them in our operation and reducing, eliminating, or even combining with other operation, we can help to actually to improve our operation by reducing the cost, the so-called the waste cost in the operation, and we make our operation become more competitive. I'm going to show you a video right now, which can be located from the YouTube. Is by HP.
Tim P. Wood. His shopping trips used to be totally disorganized and take far too long to complete. A trip to his local grocer for his needed items was a burden that kept him from his more favored pastimes. But Tim is dedicated to improvement, and he's interested in leaning out his shopping experience. He's devised a way he's sure will save him time and effort. He's organized his shopping list alphabetically, so he'll have a better idea of the items he's shopping for. Let's see how Tim's new approach to shopping is working out. Remember, before he'd just wander around his local grocers seeking the items he wanted to purchase. Now that he's alphabetized his shopping list, he's entering with a newfound confidence. Sure, he'll get his task completed in no time. Well, they'll never fit in this basket. I guess Tim should have picked up a shopping cart from the beginning. That's much better, Tim. Tim seems to be moving a lot, but he's starting to look a little tired. Deli counter, an opportunity to rest, but is this the most efficient use of his time? There's Billy, the super tall stock boy. Hi, Billy. Oh, the dog food on the top shelf. If only there were an easy way to reach so high. Still a few things on his list, but he doesn't want to alter his system that otherwise seems to be working well. Tim's wife asked him to get some tomatoes for her delicious pasta sauce. Tim doesn't know how many she needs, though, so he's getting a few extra just to be safe. Now, on to the checkout line. Oh no, whole milk! Because Tim was in such a hurry, he didn't read the label and mistakenly picked out the wrong milk. It's been a long trip for his shopping, but Tim is glad he's nearly finished. It looks like Tim still has a long way to go if he wants to shop lean. Now what wastes did you see?
Okay, so basically from this particular video, we are able to see what is the problem of this particular person as he go through the shopping. All right, so he actually make error. He actually run here and there to collect their stuff. All right, he actually buy extra tomato, all right, in order to meet the so-called the the wife requirement, but he doesn't know how many to get. So all this becomes something that is a waste in the operation. You buy too much, all right? If you are not going to use them, it become actually put into a storage. Yeah. So put in the fridge, you occupy your space in the fridge. So all this will become part of the waste of the operation. Yeah. So that is basically what Lean is looking into. All right, focusing into your operation waste. We want to reduce them so that to make our operation to become more effective in that sense. Yeah. All right. So that is Lean. The second thing I want to touch on will be what is computer simulation. Yeah. What is computer simulation? Computer simulation, basically, we can say that is using a computer algorithm to develop a digital version. We call them a model, all right? This is a model of a real life operation that inherit the real life random behavior. Yeah. So what it means over here is that you are trying to make a graphical or maybe a computer version of what is going on in the real world. It could be in the sense that your vaccination center, it could be manufacturing facility, it could be in the sense that your warehouse facility. By putting in the behavior of all this real operation into that particular digital form of the model. And hopefully from there, we can conduct in the sense that analysis. Over here, I'm going to show you another video that tells us what is computer simulation.
What is simulation? You might already know the answer, but if you don't, it can be explained in as little as 2 words. Problem solving. Should we add a new machine? How can we get rid of this bottleneck? Will we receive a positive return on our investment? Simulation can answer these and many other questions because it provides a virtual environment to learn and experiment on your process. A place where data is easy to come by and where mistakes result in improvement instead of ending careers. FlexSim is powerful 3D simulation software, built from the ground up to make simulation as easy as possible, without sacrificing an ounce of function or visual appeal. You can create beautiful, detailed models that deliver results, yet make an impact in the way spreadsheets or charts never could. And you can do it all in just minutes with drag and drop controls and easy-to-use features. So what is FlexSim? It's a problem-solving tool that allows you to accurately answer any question about your business. You'll save time and money by making better choices and avoiding the bad ones, all without the risk in physical experimentation. Contact us today for a free web demo, or let us build you a demonstration model of your facility. We would love to show you why FlexSim is the best solution for your business.
Okay, so I think in this particular video, it does point out a few things about what is computer simulation. At the end of the day, we are not trying to build create a cartoons, right? We are not trying to create a cartoon, but rather that we are using this platform to build actual real life system. And using this virtual platform, we conduct analysis to solve a problem. In the sense that in your operation, why there is a capacity issue, all right, where is the bottleneck of the operation? Can our manpower allocation assignment in the sense that is able to meet our current requirement? So some of the time, all this in the sense that in terms of management planning, we try in the sense, try and error. But in real life, we cannot try and error too much because people will not be happy. So it is good that we actually test it out, right, beforehand, before we implement it. We actually able to see what is the pro and con about such a plan. Then in the sense that we can improve the plan, reducing the con, improving the pro, such that we are able to have a more smooth in terms of the implementation. Yeah. So simulation help us to do such thing offline and without disturbing the real activities.
What is
So FlexSim basically is a kind of 3D simulation software. It helps us in the sense that allow us to build, all right, the model. The manufacturing facility, it can be a warehouse facility, a healthcare facility, transportation, airport, and any kind of facility operation that we have, all right? And we will test it, all right? We will actually evaluate it to see what is the pro and con, or maybe with using that system by putting in the data in to understand where are the long waiting time. Yeah, so that are some of the features that we have in FlexSim, and this is in 3D, and therefore in the sense that we are able to tell the story to the management easily. So the management is able to understand what is going on rather than looking at programming code. Yeah, so I think that is something that it will enhance management understanding and also buy off of the idea. So I'm going to move on to look at the case study, how actually computer simulation is being used to justify in this lean implementation of a book processing operation. First, I would like to talk about the whole project in terms of the approach that we adopted. We are using the Deming cycle. Deming cycle is basically a continuous quality improvement model, which consists of a logical sequence of 4 stages. We do a planning. Based on the plan, we do execute the plan, and subsequently we evaluate the plan, and then we act on the changes, yeah, so that we can refine the plan. And once we have done that, actually you can trigger another plan to check act. So basically, Deming cycle gives you a very systematic way to conduct improvement. So each of these particular activity will actually, when you finish, you move on to another. It can be at the end of it, you trigger another new activities. Yeah. So this is a kind of interesting thing about the Deming cycle, which is very systematic and help us to actually focus on each of the stages of the activity properly. First, I give you the background of the company. This project was conducted in roughly about 2007. Company XX is a local company that supplies books, audio-visual resources such as CD, DVD, also maps, magazine, journal, all right, under the 4 national languages to our local library. All right. So basically, they will purchase, they will process all these things before they actually send it to the local library. And the demand for the resource will increase, all right, when there are new library opens, or especially when there are new campaign, reading campaign, all right, during the June holiday or December holiday, where now instead of 1 person can borrow 4 books, now maybe 1 person can borrow 10 books. Yeah. So in the sense that all this will increase the demand of books or resources at the individual library. And hence, company XX, they have to get themselves ready to supply the book according to the library requirement. So at the planning stage, we need to define what is the problem statement and what are the challenges ahead, and therefore what kind of approach that we should adopt. First, in terms of the problem statement, XX is unable to increase their capacity effectively to meet the seasonal demand of its customer under the existing operation. All right. One of the reasons is because they doesn't know actually what is their capacity, what is their maximum capacity. So therefore, they actually will just add on manpower to actually to have overtime over the Saturday, Sunday in order to increase their capacity. But this is very short term, and long term wise, they do not know actually how can they plan for that. Yeah. So therefore, they have an issue in this area. And what are the challenges that we face under this problem statement? Number one, we have books that having 4 different languages. Yeah, due to the language nature, books are being registered or processed in a different kind of computer system or maybe the management system. So when they are processing maybe Hindu books or Tamil books, they have to make use of one system. English is another system. Chinese will be another system. So therefore, in the sense that in the operation itself, they need to switch from one system to another system that will actually jeopardize their so-called the smoothness of the operation. Second area that they need to face different kind of processes. Some of the books, they are pre-processed before actually they are sent down to XX. Some of the books, they will actually have the full process in XX itself. So hence, these books are all actually pumped into the same operation or same processing line. Therefore, in the sense that there will be a lot of switches between books that are pre-processed, the books that are processed. Yeah. Then in the sense that again, they will actually affect the operation, so-called the system, the standard. Another issue is the layout. Currently, or maybe as it, that means they are based on the island of process. All right. So what do you mean by island of processes? For example, in this particular picture itself, you can see that the cutting department, they will have all the cutting machine. Machining department will have all the machining machine over there. Welding department will have all the welding machine there. So all the layout itself is being grouped by the process. All right, grouped by the process, and hence for different book type, they need to move from one island to another island to be processed. Sometimes they are moved by trolley, and sometimes they are moved by conveyors. Yeah. And hence, because they are moving from through the same routing, same route, and some of these process they will require multiple setup or tear down because of the different book type or language type. Yeah. So that is some of the issue that we have under the layout. Another challenge that we face in this operation is that it has very high work in progress. Because the staff, they are paid according by the book they process. Once they have finished one book, basically they will push the book to the next station. Whether in the sense that the next station they are ready to process that book or not, that is not his or her so-called concern. As long as I'm able to produce as much as I can, that is my job. Hence, the line is somehow imbalanced. We can find that there are a lot of work in progress in between some of the station. And subsequently, the management also is unaware of what is the work in progress condition, the inventory condition. How much books actually is being tracked in the system? How much books in the sense that are in the sense that waiting for something to happen? Yeah. Nobody know what is going on. Yeah. So in the sense that there is a high WIP, but the problem is that we will see that a lot of books around, but we do not know how much books is around. Yeah. So that is also one of the challenges the company is facing. And movement of books, as I mentioned earlier, books are being moved in a tote or transported between the workstation by conveyors. Books are actually pretty heavy inside the tote. Each of the tote, they have about 20 books or so. So therefore, in the sense that if they need to carry the tote one by one, it will be very heavy. So normally they are either transported between the station using a conveyor, or in the sense that they are being piled up using the trolley and transfer from one island to another island. So if they are using trolley, they tend to, in the sense that put a lot of totes onto a trolley before actually they move. And hence, for this case, we can see that in fact, the books are being pushed to another station rather than pulled when there is a requirement of books itself. And because of that, again, this actually again contribute to a lot of high inventory over the operation. Lastly, the visualization of the operation. The company, again, they does not have much of the visualization of the workflow. They do not really have a proper so-called SOP, how the material flow from one station to another station. They do not know how much time it takes actually to process different books and do a setup or tear down. No information about that. As I mentioned, they also doesn't know their work in progress, and hence at the end of the day, they also does not know what is the maximum capacity. Again, because all the books are pumping into the same operation with the different so-called type of book, actually it does affect the maximum capacity that the line can actually produce. So therefore, in the sense that the company doesn't know any of this kind of information for their operation. So the approach is, because they have no information of all this, then in the sense that we will need to, in the sense that plan our execution to actually to collect all this data, to understand what is going on. Yeah. So in terms of planning wise, we need to conduct a data collection. And a lot of information is already in the sense that in terms of maybe work in progress, all this is already in the past. Hence, they do not know of the historical information as well. So therefore, in the sense that we need to use a simulation again to recreate the history for them to understand some of these operation parameters. Yeah. So in terms of the do phase now, in terms of project execution, step one, we actually do the data collection. We actually measure up the layout of the operation. We conduct time study to determine the standard time and also the time standard. We also measure up or draft out their workflow. And subsequently, we also try to understand what will be manufacturing lead time through the simulation model as well. So this is a part of data collection that we conducted before actually we do anything. Subsequently, the step two, with this information, then in the sense that a computer model of the operation is being developed. And this model helps us to evaluate the seriousness of the as-it scenario. That means their current scenario at that point of time. So this is a model that we have created, all right, that shows you the layout itself. The gray color boxes are the tote, all right. The item over here, actually, they are the books, yeah. So you can see that there are a lot of totes around, there are a lot of books around, there are a lot of conveyors around in the operation. Next, I'm going to show you a quick video of the operation. That is, this video is recorded using the model that we created. So after running the model for about a month, then we begin to collect the so-called the result from the simulation. By the way, all the data that come in are actually through the historical data. For example, the number of books type that they have, all right? And from the time study, we collected the setup time, the cycle time, all those things. All these things we will actually pump into this particular model. And from the model, after completed running, then we conduct a check cycle with the stakeholder to validate the simulation result. We actually find out that the shortest time that they take to complete a certain book type is about 2 days. And the longest time is about 7 days. And that is under the mixture of the different books that actually pump into the so-called the operation. And also under the same scenario, we realized that with daily about 7,000 book input to the line, their output is roughly about 4,000. Yeah, 4,000. And their WIP cumulated per day will be roughly about 40K in the system. All right, 40K in the system. So therefore, you can see that there are a lot of WIP actually in the system itself that are not being pushed out. And other than that, we find out other ways such as overproduction. Books are being pushed to the next process regardless whether the next process are ready. There are movement ways. As I mentioned, the books are being transported by trolley. And you can see that on this particular picture itself, by right on the conveyor, you should have one tote by one tote. You can see that in this picture, the tote are stacking up on one another. So basically, WIP are being formed within even the conveyor. All right, WIP are being formed within the conveyor. So conveyor is become a very good place for them to keep their WIP. All right. So basically, in the whole system, it has a high WIP situation. And also in the process itself, we find that there is a tear down and a setup waste because they need to switch from different language, all right, a production management system due to the language of the book use. Also, we realize that because there's no standard operation procedure, a lot of ways, a lot of things, a method in the sense that it's really depend on the preference of the operator. So maybe operator A like to do this thing by this method, that operator need to do operator B do by another method. Yeah. So there is no standard operation procedure for that. Yeah. And we also find that they're actually out of the manufacturing lead time, actually roughly about 90% of the time the books are in the waiting stage, which is again a non-value added activity, waiting 90%. If we are able to reduce this percentage, the books will be able to purge up from the system in a shorter time. Yeah, so this will become a waste. So we make a proposal under the Act based on what we have studied. Number one, we requested them to throw away their so-called conveyor, and they need to streamline the book based on the book and also the process type. Yeah, so that form in the sense that what we call a U-shaped line over here that you can see on the picture, which is on the right-hand side. So this line is basically for one type of book, one type of process. So this particular line will contain all the station that is required. Hence, there is no transportation between islands. So now in the sense that everything is within one line itself, so they do not, the whole layout is no longer in island form. And hence it reduced time is switching from the so-called the production system, especially over the language, because this line only handle one type of book, right, or one type of process. Secondly, we introduce this thing we call it Kanban. Right, Kanban basically is a signal to produce. Right, without Kanban, the operation, the previous operation is cannot produce or cannot process anything. Right, so Kanban become a kind of limit or constraint for the upper or upstream station based on, in the sense that the downstream station availability. So if there is no cuts, which we use the cuts as a Kanban, you can see the picture on the right-hand side. Each cut itself, there is a number of code allowed to be stacked on top. So they do not have this cut, they cannot process anything, right? They cannot process the book and place on the table. It is not allowed. So they must base on the availability of cuts. So once the cut is being sent to downstream, when the downstream consume all the books in these particular cuts, the cuts will be returned back to upstream. So hence, in the sense that we are using this methodology to, in the sense that to control the operation, to limit the number of WIP that is in between the two stations. So instead of pushing, now actually they need to pull, right? We are saying that this is a pull process. And the management need to justify this proposal. All right, the management need to justify this proposal. They need to see what is the impact. They need to see what will be the potential risk. All right, so in the sense that we need to align with the management expectation on this particular proposal. So hence, a second cycle of the Plan 2 Check Act in the sense that it started. So again, for this time, we plan for another model, all right, to be developed, all right, based on the new proposal that we have. And hence, with this new model that we develop, we try to understand now in the sense that what is the lead time, what is the maximum capacity, what is the work in progress, and even the floor space. Yeah. So basically, we want to actually do that. And hence, we actually conducted this model. All right, we do the model. And you can see that the one on top is the model of the one below. Yeah. So with that, we will have all the process over there. And subsequently, this particular line, which I mentioned, which only cater for one type of book and one type of process, they are kind of modular system. Hence, in the sense that they can be set up or tear down easily because they are just make up of general workstation. Yeah, so they can set up and tear down easily. One of the advantage of having that is to say that if the customer is they need to increase in terms of demand, they actually can build this line in a very short term. Right? Do not need to have a very specialized equipment or whatever. Yeah, so they can actually build this line very easily. So we use a simulation model again to justify, to actually to do a data collection, to compare in the sense that to collect the data about each of the individual book type, what is their processing time, their WIP, right? In order to see what is the advantage and allow the management to expect what is going on with this new implementation. And finally, we got the result for the simulation. And we realized that the shortest time now, in the sense that instead of 2 days, now become 2 hours. Longest from 7 days, it become 3 days. So therefore, we are able to show the management through the simulation by implementing Lean. We actually improve the whole processing time from 2 days to 2 hours, 7 days to 3 days. Yeah, and about the maximum capacity, because now is individual line. All right, it's no longer a mix of product going through the same line. We are able to see the maximum output from the line is 7K. So almost whatever that you have pumped in is out. All right, is out. Yeah. Previously, you pump in 7K, you only got 4K to come up. So now, in the sense that we are very clear what is the capacity of each line. So once the management is clear about that, they can make production planning. All right. Previously, they are not clear, so they cannot do anything about it. And based on the WIP with the introduction of the Kanban, we have only roughly 7K of books in the system from 40K. Yeah, so that again is a drastically reduction in terms of the WIP. And we also realized the new lay area that we have done. There is a reduction in terms of the area usage by 20%. All right. So these are some of the results that we actually collected from the simulation. We make this to proposal to the so-called the management, saying that, okay, Lean is good. And through simulation, we have proven that you can achieve this kind of result, all right, through the Lean implementation. And subsequently, the management is happy about that. But however, they also would like to do their own plan, do, check, act. So therefore, actually, they do a small scale physical implementation within their operation. After about 6 months, all right, then after 6 months, they actually do a full implementation throughout the whole process. So in conclusion, Lean for this case is actually a very good tool to help XX to improve their operation. Yeah, we can see that the overall productivity of individual worker for this case actually improved by 25%. We are able to shorten the processing time at least 92%. All right, for the few days to 2 hours. Reduction of area space, lowering the manpower requirement. And now the line is modular. They can set up, they can tear down easily. They can increase the capacity, reduce the capacity easily. And now management have a very clear information on what is the operation about. Yeah, they can do their planning, they can manage their operation. Previously, they don't know how to manage. Yeah, so actually Lean helped them in the sense that able to achieve all this. But as I said, in order to allow the management to able to have the visualization to manage their expectation, simulation come into the picture to prove that concept. So simulation technology have proven the concept of Lean is workable in this situation. We are able to address the potential concern from the management and facilitate the management to manage the change by knowing what is going to happen. Yeah, what's going to happen. So in the sense that the company is very happy about this implementation. All right, that will come to the end of my presentation. All right, if you would like to talk to us more, then you can actually spend on this QR code, all right, that you can find out more information from our company website. And lastly, this is the QR code for the Smart Nation. All right, so we appreciate your feedback, all right, through scanning this QR code as well. Yeah, thank you so much.